Hello, everyone, and welcome to our 16th class. No, our 15th class. We missed one. So hello, everyone. Welcome to class number 15, Jesus. And we're going to start by going over the quiz from last time. So I'm going to share my screen and we're going to go over it. Okay, when playing craps, you can make an 11 bet where you win $16 if the sum of two dice is 11 and you win nothing with any other sum. Okay, so those are the important pieces of information. Part A, make a probability distribution that gives all possible outcomes of one roll.
Sorry I'm late.
Lori.
Uh-oh.
How can anyone stay mad at you?
I know.
All right, so make a
Well, let
probability.
me tell you. No, just kidding.
So make a probability distribution table.
Please tell us.
That gives all possible outcomes of one roll of the dice. Remember, we're dealing with two dice here. So what are the possibilities for the outcomes for one roll of the two dice? What are our possible outcomes? Well, we can get a 2, a 3, a 4, 5, all the way to a 12, right? Those are the outcomes. Yes? And we've already done this before, so this part wasn't new. But the probability distribution, what is the chances of getting a 2? Well, it can only happen in 1 out of the 36 ways. And how about a 3? That can only happen in 2 out of the 36 ways, and so on. So part A was nothing new. That should have been okay. So use a formula to compute the expected value of one roll of the dice. So all you do is you take every possible outcome and you multiply by its corresponding probability and you add them all up. That's the formula we learned. So 2 times 1 over 36 plus 3 times 2 over 36 all the way through 12 times 1 over 36 again. And then you just take out a calculator and you do it. And the answer should be 7. C, it costs $1 to play craps. What is the expected win or loss, say which, for a player on each roll of the dice? Now, we're dealing with this problem here. So there's two possibilities. Either you lose $1 or you win $15. You make an 11 bet. Either you lose $1 or you win 16, but of course you spent 1, so really you're only winning 15. So what's the chances of losing $1 and what's the chances of winning $15? Well, how many ways can you get an 11?
Professor, I can't see. Can you please scroll up?
No. What can you not see?
C. I can't see C. I can't see what you're writing.
Okay, well, I'm gonna have to delete. First of all, I have 6 chats. Wow, when did that happen? Hi man in the back. What? Oh, show and tell. That's right. All right, so I'm gonna delete what I've written so far. So here is part C. Can you see it now? I hope so.
Yes.
Right, so you can either lose $1 with probability 33 out of 36, or you can win $15 with probability 3 out of 36, because there's 2 ways to get an 11, not 3 ways. Uh-oh. So let me fix that. Sorry, my apologies. 2 ways of getting an 11, and therefore 34 ways of not getting an 11. So the probability of not getting an 11 and therefore losing $1 is 34 over 36, and the probability of winning $15 is 2 over 36, and you add them, and the answer is -1/9. So approximately negative 11 cents. So the expectation is that every roll you lose 11 cents. Now, the prizes in a school raffle are 30 movie tickets worth $14 each for a total of $420. There's 10 Hatchimals worth $60 each for a total of $600. There's a new bicycle worth $500 each, or worth $500 for a total of $500. And we want to split this cost evenly amongst the 200 tickets that were sold. So the answer is $6.60. Fun? Fun. All right. So I'm gonna stop sharing this. And I am going to load up the next PowerPoint. The next PowerPoint, what was the last one that we did? We probably did displaying quantitative data, correct? Or did we do measures of position? No, of course we did, because that was a test. What was the last one that we did?
Sorry, is number 4 660 or 760?
Well, I did it from memory, and I seem to recall it being 660, but maybe it was 760.
I also got 760.
Maybe
I
maybe-
also got
760.
760.
Hold on. So,
760.
wait, so it was 420 plus 500 plus 600, was it?
500.
Divided by 200. Yeah, 760. So 760, not 660. I was just doing it from memory. I didn't do the calculation just now. I was just trying to, I have it written down somewhere. So yeah, 760. So my apologies. That will be the answer for that one. Okay, so which one are we doing now? Which what was the last section that we did? Anyone? Oh, thank you. That's so sweet, Angela.
Quantitative data.
So we did quantitative data, 10. Did
Yeah.
we do 11 measures of position?
No,
Really?
I don't think so. Not
Okay.
ringing a bell.
Okay, so let's load up 11 then. That seems reasonable because my other class just did
Yeah.
12 and we're a day
No,
behind, so 11 makes
It's
sense.
okay.
Okay, so here we go for chapter 11, measures of position. This is actually a relatively straightforward. My other class felt this one was relatively straightforward. Hopefully you guys will feel the same way. So number 11, example, the graph on the next page was made using Social Security Administration records. So here we have a graph. What kind of graph is this? Well, we'll get to what it's called later, but let's not worry about the deets right now. Let's just see what it says. It says it's listing us the median ages for females with the 25 most common names among Americans estimated to be alive as of January 1st, 2014. Emily, Ashley, Sarah, Jessica, Anna, and so on. I do notice I do not see a Lori here. Interesting. I would think Lori would be extremely
Very surprising.
popular, 'cause Loris are always
I know.
cool. Yeah. But there's an Angela. So, no, is there an Angela? No Angela either.
Patricia. Woo woo.
There's a Patricia right there. We got it. Of course, it was Sarah. I know we have a Sarah in the class. Anyways, so this is a graph. So the median, this is an important term, the median for a given name is the age at which half of the females are younger and half are older. Okay? Half are younger, half are older. So according to this chart, the median age, because the red dot tells us it's the median age of Emily's is about what, 16, 17 years old? Because this line here is 15, this line here is 25, so it's closer to 15, I don't know, 17, whatever it is. That tells us that half of Emily's are younger than 17 and half of Emily's are older than 17. Would that imply that Emily is currently a popular name?
As far as 2014 is concerned.
As far as 2014 was concerned, when the study was done, would that imply that Emily was a relatively popular name?
Yes.
Yeah, because half of the Emilys are kids. They're under 17 years old. And the other half are anywhere from 17 to, 100 a gazillion, or whatever, however old people can be. So there's lots of ones that are young, and the ones that are old are spread out. Okay, so the median is the halfway point. Half are below, half are above. That's by definition what the median is. Okay. So the median for a given name is the age. Estimate the median age of the Emilys. So the Emily median age will be about 16 or 17 years old. Okay. Now, the endpoints of the boxes are the 25th and 75th percentiles. The 25th percentile for a given name is the age at which 25% are younger. And therefore, of course, 75% are older. So what will be the 25th percentile for Emily's? Roughly. What is the 25th percentile for Emily's?
Maybe like 2 or 2%.
Now, what age? What age is the left edge of the box?
Oh, 15.
No, I don't think 15 is the right edge
5?
of the box.
Maybe 5.
Well, no, because if you look at the size of from 15 to 25, this length is a 10-year length. So if I pick this up and move it there, then this is where 5 would, oh, that was awesome. Then this is where 5 would be. So the left edge of the box seems to be about what?
10.
10, maybe 11. Okay, does that make sense? Okay, so that tells us.
Sorry, I estimate the median age of the Emilys? You said that's 15, about halfway through.
No, the median age is definitely not 15.
Oh, that first line, that's right.
The median age is like 17.
17. Okay, sorry.
Okay. So it looks like the 25th percentile would be roughly maybe 11. And what is the 75th percentile for Emily's? Anyone is free to answer.
Zip.
What is the 75th percentile for Emily's?
There's none of them that are 70.
What do you mean? The 75th percentile is the right edge of the Emily box.
Would it be 26?
About 26.
I was looking at 75 years old, sorry.
No, 75 years old got nothing to do with Emily's. Emily is the first line.
We're just looking at Emily.
Just looking, this whole question was about Emily's. That means 25% of Emily's are younger than 11. 25% of Emily's are younger than 11. 25% of Emily's are between what two ages? 11 to what?
17.
11 to 17. The next 25% of Emily's are between what ages? (17) to what age?
26.
To 26. And the next 25% of Emily's are between what ages? 26 to what?
75.
Not 75. 26 to death. 26 to death. 26 and on. 26 and on. So 25% of Emily's are less than 11, 25% are between 11 and 17, 25% are between 17 and 26, and the last 25% are from 26 to whenever. Okay. So if you look at the Dorothy box instead, okay, it's very different than Emily in terms of where, I mean, how many Dorothys do you guys know who are your age?
Not one personally.
Not
Wizard
Dorothy.
of Oz. Come on, you guys. She's like our age.
She is. That's a cool name, though.
So Dorothy is not really a name that's in style.
I know a Dorothy.
I'm not saying there's no Dorothys. I'm not saying it's impossible, but would you agree that it's not quite as common as Emily or Ashley or Sarah,
Or Megan.
right? Or Megan. Megan's a nice name. All right. Dorothy, Betty, Helen, Francis.
I like the name Lori.
You like the name Lori?
You too?
Oh.
I never have liked it. I don't know.
Yeah, it's
Thank you, Angela.
It's very sweet. Okay, so anyways, here's the idea of the 25th percentile, the median, and the 75th percentile. Okay, the 25th percentile is the value for which 25% of the data will be less than it. The median is the value for which 50% are less than it. The 75th percentile is the value at which 75% are less than it. So these three values, the 25th percentile, the median, and the 75th percentile, they divide up your data into roughly 4 equal parts. Okay. Which name is the box the longest? Which name is the box the longest? Anna, right? By far, correct? So Anna seems to be a name that has not really come and gone from style, or out of style, right? It's essentially half of the Annas span a very wide range from, I think, 14 to 63. And then 25% are less than 14. So you still have lots of Annas. I have a very good friend named Anna. Okay. Wendy and Crystal, will you be the godparents to Dorothy? What is going on here? I don't know what's happening. Let's focus. Focus. Okay. Percentiles. Test scores. Ow. Test scores and physical characteristics such as heights are often reported as percentiles. So a percentile is a score, or let me rephrase that. A score at the kth percentile means k% of scores are less than or equal to that score. Again, if you are at the 30th percentile, that means 30% of the values of the scores of the data points, whatever they are, is less than your value. If you're at the 80th percentile, that means 80% are less than your value. Who here is a kid? Who here has ever taken their kid to the doctor when the kid was a baby and you get a report about the weight or height of your kid as a percentile, right?
Our youngest was always in like the 80th percentile.
So what did that mean, Lori, that they were in the 80th percentile?
He was a big kid.
Okay, so in other words, he was bigger than 80% of the other kids his age.
Yes.
Right? He was on the far right side. Now, is that useful information? Let's go to the bar mitzvah. Is that useful information? Certainly, because if the kid is undernourished, maybe they're on the lower end of the percentile, they can check for conditions or diseases. I'll give you an example.
No. I was like the 3rd percentile, and I'm fine. It's because I'm little.
Nothing wrong with that. Okay, but as a counterpoint, my niece was always very little for her age, and they finally took her to get checked out, and she has Crohn's disease.
Oh.
Okay, so sometimes being on the upper end or the lower end shows a medical condition, right? So it's very important to know this information. Okay.
He just turned out to be 6'3", so.
6'3".
Uh-huh.
Damn.
How old is he? Trying to hook up Angela here. She's single.
20. He's 20. 20. Yeah, he's 20, just turned 20.
Angela?
Perfect.
Angela?
Perfect.
Okay, after class, you guys will have a little, get together and we'll see if you guys hit it off.
Matchmaker, make me a match.
Okay, so next slide. The cumulative percentile, the cumulative percentile or percentage plot shows the amount of change carried by 200 students. Okay, come on, guys. So let's get back to math. Math first, funniness and enjoyment of class second. But we got to make sure we learn at the same time. Okay, so the cumulative percentile or percentage plot shows the amount of change carried by 200 students. So let's take a look at this diagram. What percent of these 200 students carried no change?
0.
No. What percent of the 200 students had no change on them?
18%.
Roughly 18%, 17, 18. I mean, it's hard to see exactly, but somewhere in that vicinity. What percent of students carried less than 25 cents with them?
59%.
Yeah, 58, 59, somewhere around there. What percent carried less than 50 cents with them?
63.
About 63%, right? Which is the answer to the first question, right? What percentage of students carried 50 cents or less? About 60%. How about $1.50 or less?
About 85 or 80, I don't know, 80, 90, 89 or 88.
Yeah, 90, something around there. Again, without a more accurate scale, you're not expected to know the exact value, but somewhere around 90%. Okay, so now let's flip it. A student at the 40th percentile had how much in change?
The 40. Well, maybe like 25 cents.
Well, here's what you do. You go to the 40th percent and you go until you hit the graph. And then you go down to figure out the value for that point, which is about what? 15 cents, give or take?
I'm thinking
20 cents? I don't know. Again, it's not
25.
It's not 100% accurate, but it's ballpark. Okay. How much change did a student at the median have?
I forgot what the median is.
The median is the midpoint. It's a point. It's basically the median is the 50th percentile. It's the point at which 50%. Sorry, Angela, what?
Oh, I was gonna say like 25.
Well, let's take a look. Here's 50%. Oh, I'm going to cheat, actually. Hold on. Watch this. Watch this.
Wait for it.
Look at that. Look at that. Look at that straight line. So, yeah, about 25 cents, give or take. So, are these graphs relatively easy to interpret?
Yeah.
Anyone have a question on it? Okay. So, medians and quartiles. So out of all the percentiles, 3 of them are special: the 25th percentile, the 50th percentile, and the 75th percentile. They have special names. The 25th percentile, also called the first, is called the first quartile because it's a quarter of the data, 25%. So instead of calling it the 25th percentile, we call it the first quartile. The 50th percentile is the median or the second quartile. And the 75th percentile is the upper or third quartile, denoted Q1, Q2, and Q3. So you take the data, you divide it in the middle, that's your median, that's your Q2. Then you look at the left side, you divide that in half, that's your Q1. The right side, you do that in half, that's your Q3. We'll do some examples in a minute. Okay, so let's actually go right to our examples and I'll walk you through how to do it. So the question here is to find the median and the quartiles for each of these groups of numbers. Find the median and the quartile for each of these groups of numbers. So the first thing you always do when it comes time to finding the median or the quartiles is to do what? What must be the first step?
Put them in order.
Put them in order.
Excellent. Put them in order. 1, 4, 6, 7. I like to cross them out when I write them so I don't miss any. 1, 4, 6, 7, 8. Cross that one out. 10. Cross that one out. 12. 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7 numbers. Right? Just a couple double checks. With me so far? You can't cheat with the numbers like you do with the lines. What the hell does that mean? And no judgment, but what are you saying? Come on, you said the fire drill can't be still going on. Speak up. Why can you type the Well, you don't like my numbers?
No, I think they're beautiful.
Thank you. Okay, my numbers are wonderful numbers. Jeez, back in my numbers. That's crazy. So here's what you do first. Looks like a Have I ever told you about my second grade class? When I won best penmanship in second grade in Miss Morris's class? Have I ever told you about that?
You told us.
My finest achievement of my entire life, and she's knocking my penmanship. Yeah, here we go again. Wow, okay, you just failed. All right, step 1, put them in order. 1, 4, 6, yeah, I did smile, that's true. 1, 4, 6, 7, 8, 10, 12. So the first thing you do is put them in order. Next thing you do is you find Q2, the one in the middle. Now, if there's an odd number like there is here, then there is a middle. What's the middle?
7.
7. So Q2 is equal to 7. Then you look to the left of 7. You never include Q2. You always look to the left of 7 and find the median of that. What's the median of 1, 4, 6?
4.
So Q1 is equal to 4. And then you look to the right of 7 and you take the median of those.
10.
And therefore Q3 is equal to 10. So you have Q1 is 4, Q2 is 7, and Q3 is 10. Go ahead for a moment and do the next one. Okay, what's the, oh, hold on. Hello?
Yes.
One second, guys, this is important, hold on. You guys finish the problem, I'll be right back. David's here, yes. Perfect, thank you. Okay, bye. Sorry, that was important. More important than you guys, no offense. Okay, so let's go back here to question number 2. What's the first thing we do?
Put them in order.
Put them in order. So we have 1, 4, 5,
That's
6,
7,
7,
8, 10.
8, 10, 12, 14. Okay, is there an odd number?
Yes,
So what is the Q2?
7.
7. Q2 is 7. Then we look to the left of 7. And we want the median of that. When I look to the left of 7, how many numbers do I have?
4.
4. 4 numbers does not have a middle one, like an odd number do. 4 is even, correct? So what do you do in a situation when you have an even number of numbers?
You take 4 and 5 and add it.
So you get 9?
Then divided by 2.
Okay, so you take the 2 numbers in the middle, you add them, divide by 2, and that gives you that Q1 is equal to 4.5.
So if you had 3 on each side, you would just take the 2 middle numbers, add it, and
No,
divide
no.
it
No. If you have 3 on each side, that's an odd number. You don't got to do this.
by... No. Sorry. You know how there's 4 on the left? If you had 6 on the left, sorry, let me rephrase it. If you had 6 on the left or 6 on the right,
Yeah.
you would take the 2 numbers in the middle, you would add it, would you just divide by 3 in that situation, or you would divide by 2 still?
Always divide by 2. It's the
Okay.
average of the 2 middle ones.
Okay.
Okay.
Sorry.
No problem. Now let's find Q3 in the same situation.
11.
So Q3 would be the average of 10 and 2. So Q3 would be 11. Right? Because there's 4 numbers. You look at the 2 in the middle, 10 and 12. You add them and you divide by 2. Do we agree?
Yes.
Agree.
Okay. Go ahead and do the next one, please.
I disagree.
You disagree?
I'm joking. It was a joke.
Oh, sorry. My sense of humor is horrible. Well, no one said anything. Okay.
We love it.
Thank you.
This is a tricky one.
Well, first, do step
I mean,
one.
if you have the, yeah, I'm just saying it's different than.
Okay. So first step is what?
Put them in order.
Put them in order. 1, 3, 4, 8, 15, 15. Next step.
You would 1, 2. You would add 4 and 8 and divide by 2.
So what do you get?
9, 10, 11, 12. 6.
Excellent.
Q1 is 6.
No, Q2 is 6.
Oh, Q2 is 6. Why Q2? Please remind me. And not
Q2 is the
Q1.
middle one.
Oh, they're 2 numbers. They're not 1. That's why.
No, we always get Q2 first.
Oh, okay.
Right, we always get Q2, and then we get Q1 and Q3.
Okay. Could there be a Q4?
No, Q1,
Okay.
Q2, Q3, separated. It's 25%, 25%, 25%, 25%. So Q2 is 6, which is somewhere in between 4 and 8. What's Q1?
Three.
3, and we're done. There's an odd number. It's the one in the middle. What's Q3?
15.
15. Odd number, one in the middle. Go ahead, please, and do the last one, which hopefully you can see. I'll give you a minute or two on those. Oh. Whew. What's that? All right, so let's put them in order. What's my order here?
1,
1,
2,
2,
3,
3,
4,
4,
8,
8,
10,
10,
12,
12,
15,
15, 1, 3, 4,
35.
5, 6, 7, 8, 5, 6, 7, 8. Huh?
35.
There you are, trying to be funny again. Oh, I caught it this time. I recognize it for what it is. Too bad it was horrible. Okay, so now that we have all the numbers, what do we do next?
Find the middle.
Find Q2. What's Q2 in this case? Uh-oh, someone texted something.
6?
Huh?
Is it 6? Because you add the 8 and the 4 and divide by 2?
That's right.
No?
100%. Right? You take the two middle ones and you divide by 2. How do I find Q1?
Add 2 and 3.
Well, hold
divide by
on a
2.
second.
Huh?
So what's Q1 equal to?
1.5.
Try again.
2.5.
Oh, 2.5.
2.5.
That's what I meant.
And what is Q3?
11.
11. Right? Notice that none of them are actual data points in this case. All three of them land in between. But in every situation, we do exactly the same thing. Put them in order. The middle one, the middle of the left, the middle of the right. That's how you find your Q2, Q1, and Q3. Are there questions on that?
What do you mean none of them are data points? Sorry.
Well, here are my data points, right? Those are my data points, right?
Uh-huh.
None of these three numbers appear on my data list.
Oh, I see. Okay.
Right? None of them are actual data points. So we're going to skip that one. Okay, so here we have the 5-number summary and box plots. The 5-number summary and box plots. 5 numbers summarize the data. What are those 5 numbers? The minimum value, Q1, Q2, Q3, the maximum value. I already told you how to find Q1, Q2, and Q3. How do I find the minimum and the maximum?
The smallest number and the largest number?
Yeah, not that hard to find, right? It's just the smallest and the largest. So once you put them in order, the smallest number is your min, the biggest number is your maximum. And what we do is we display this data in something called a box plot. A box plot is a line, a box, a line with a vertical line in the middle of the box. This is the box plot. The end of the line is the minimum. The box starts at Q1, ends at Q3, and we have a median, and the last line ends at the maximum. So the 5 points here, 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 and here, those 5 numbers are your min, Q1, Q2, Q3, and the max. That's your 5-number summary of the data. So for example, the box plot below summarizes the scores of 20 students on an exam. What was the minimum score of these 20 students?
39.
No. What was the minimum score of these 20 students?
65.
No.
50.
50. The line ends.
Oh, you're looking
right
at that box. Duh.
That's the box plot. The whisker ends at 50. That's the minimum value. What's Q1?
80.
75, 80.
80. Q1, right there, 80. What's Q2?
90.
90.
No.
90.
100.
Q2. What's Q3?
100.
100.
Okay, I have a question.
Hold on.
The
What's the maximum?
110.
110. What's your question?
you just answered it. Never mind.
5-number summary. 50, 80, 90, 100, 110. Based upon this, would you say that this was a hard test or an easy test? Assuming it's out of 100, of course.
Is the box how much most of the kids got that score?
I want you to interpret it. That's the whole point of this question. Right? Your goal is to interpret the box.
Asking like what we think it based off of like our cues, if we think it's a hard or an easy test.
That's right.
Easy.
Easy
Hold
test.
on. Yeah.
What makes it easy?
Well, the fact that
Because a
the
lot of
Oh,
people
no, no,
got
drop the
90.
yeah.
Well, one second. How many people got 90?
Q2.
I mean, what was the lowest score in the test?
A 50.
See?
Of 50, right? And what was the
50?
highest score?
110.
110.
Okay, so you got a really bad student and you got a really good student, right? You can't really use those by themselves to determine whether or not the test was easy. However, what percent of students scored between 100 and 110?
75.
How much?
75.
I couldn't hear the first word.
75.
No, not 75.
Okay, I was kidding.
How many students scored between 100 and 110? 25. Excellent. 25. Every portion is 25% of the data. So above 100 to 110, 5 students fell in that section. Between 90 and 100, how many students were in that section?
25.
How many students? There's only 20 in the class. Can't be 25 students. 5. That's another 25%, which means half the class scored above a 90. How many students between 5 and 80? Sorry, between 80 and 90.
10.
That was stupid. 5. 25%. 5. And then 5 students scored lower than an 80. Which means the majority of the students did very well on this exam. Chances are it was either an easy exam or they were just good students. Probably it was an easy exam because, you know, students are not always good. You guys will know this when you teach. Most students, when they're learning something, are not amazing. I mean, you are all amazing. You are my best class I've ever had in my entire life, of course. But in general, it's not nearly as good. So we're not going to do that. We're not going to do this. And we can do this. 2 psychologists randomly divided 139 students into 3 groups. Group 1 learned the names of the others using the name game, where the first student states their full name, the second student states their full name and that of the first student, and so on. So, for example, I would say, my name is David Berkowitz, and Angela would say, my name is Angela Christopher, and this is David Berkowitz. And then Lori would say, my name is Lori Cook, and this is David Berkowitz and Angela Christopher. And you'd go down the line where you would keep repeating all the names that came before it. Group 2 learned the names using the name game, with the addition that each student stated their favorite activity. So I said, hello, my name is David Berkowitz. I love to eat, for example, okay, or sleep, all right? And Angela said, hello, my name is Angela Christopher. This is David Berkowitz, and I love math class. You know, we all say our favorite activities, okay? In group 3, each student learned the name, let's play real quick. Each student learned the names by going around and introducing him or herself to each of the other students. 1 year later, the students were sent photos of the others in the group and asked to give the names of as many other students as he or she could remember. The variables recorded for each student was the percentage of names that he or she recalled. Here are the results. So they are listed as a box plot. If you look at group 1, for example, you'll notice that there's one person who really did amazing. And that person is an outlier that's so far removed from the rest of the data that what we do is we modify the box plot. We don't have the whisker, the line, go all the way to that person, because that person is so strange in relation to everyone else that we put a little dot there and say, okay, there's someone over there, but the next best was over here. So the dot, the line doesn't go to the maximum necessarily, but it goes to the maximum non-outlier. So based upon these 3 box plots, which method would you choose as the most effective?
One.
Why 1? What is it about 1 that makes it the most effective?
Is it because it's closer to or beyond the median or whatever? No.
Well, I'm asking you. I'm not saying you're right or wrong. I'm asking you for what you believe the answer to be. I'm not saying it's right or
It's
wrong.
closer to 100. I don't know.
What? No. Don't give up so easily. I mean, what are you saying?
Well, I am thinking that
Yes.
if you compare all of them, it's closer to 100. But I don't know.
Okay.
Not
Does
giving
any-
up. I'm just not sure if I'm understanding. it
That's
correctly.
fine. Does anyone else have a guess?
I think Lori might be right that the first one, because it shows you the outlier, but it's also more it would be more accurate to the numbers that are given. I mean, because then the other ones, don't they like have to modify it or somehow? I don't know. I'm just, yeah.
But wait, actually, does that have anything to do with the group 3 had to remember the most stuff? No.
Well, look at group 3, for example. A full 50%. Where's the median for group 3?
At 10. Wait, 5, 10.
About 9%, maybe. That means that half of the people could remember less than 9% of names. Right? Half the people can remember less than 9% of names, correct?
Right. Okay.
Now look at group 2. Where's the median for that one?
25.
About 25%. So half of the people could remember 25% of the names. Where's the median for group 3?
28. I'm sorry, group 3. Sorry.
30 something, right? 31, 32. So that tells me that group 1, half of the people could remember over 30%. Whereas with group 2, half of them could remember only 25%. And with group 1, half of them could remember less than 10%. Right? So the median is a wonderful measure of center. There he is.
Oh, where?
Liam, what's up?
I
Hi.
see.
Hi. Hey, I'm over here, kid. Eyes up.
Hi,
All right. Anyways.
Half baby.
I don't want to do this one. I don't want to do that one.
So what was it?
Oh, so my answer is that 1 is the best
Okay.
because the median is the highest.
Okay. Thank you.
That's my answer. Let's do this last one. So the box plots on the next page show how efficient box plots can be in displaying a lot of information. Let's first look at them. So, Angela, this is very important. Generally speaking, people want to date others who had higher ratings across all attributes. Right? So you have attractiveness, fun, intelligence, ambition, sincerity. Unfortunately, height does not seem to be one of them, but I don't know, maybe that's part of attractiveness. Who knows? Okay. So the researcher who made them explains a few years ago, I downloaded speed dating data from experiments conducted by Raymond Fissman et al. 2005, which represents about 8,000 dates by 551 people. On each date, people scored each other on attractiveness, intelligence, ambition, and some other things, along with a yes or no to seeing the other person again on a regular date. For example, the rightmost box in the set of box plots on attractiveness represents all the people who got a median rating of 9 on attractiveness from other people. So,
Excuse me.
you're excused. So, here we have the attractiveness one. Angela, pay attention. So here we have the attractiveness one. Stop talking to that person off the screen. I'll give her or him a talking to. Unless it's Patty, of course. Is that Patty?
No,
No. What's she writing
we
now?
are 5 hours apart.
What do you mean you're 5 hours apart?
I'm 5 hours away from her right now.
I'm just like a little emotional. I'd like to not talk about it.
That's fine. If I was away from her, I'd be very happy too. So, okay. So generally speaking, people wanted to date others who had higher ratings across all attributes. So let's look at this first one here. So what's going on here? 2, 3, 4, 5, 6, 7, 8, 9. In other words, if someone had an attractiveness rating of 2, what percent of people wanted to go out with them, according to this? Basically, nobody.
Nobody.
Story of my life. Now, if they had an attractiveness rating of 3, you'll notice that there's some people who wanted to go out with them, but still not very many, right? But across the board, as the attractiveness rating went up, then the percentage of people who wanted to go out with them also went up. Agreed? That seems very realistic. If you look at intelligence, there's not really so much of a similar trend. I mean, as you get more intelligent, more people want to go out with you. But if you get super intelligent, it actually goes down, right? Which is quite interesting. Okay. Ambition. If you have no ambition, yeah, okay, no ambition. This guy's a loser or whatever. But once you have a certain amount of ambition, then it's kind of like, okay, it kind of stabilizes, right? How much fun you want to have, again, stays basically the same in the beginning and then shoots up. And sincerity, okay, if you're low on sincerity, you still have people want to go out with you. But you can really tell from this one that this is the most, Angela, are you there? You can really tell from this one that it has the most dramatic increase across the board, right? So 5 box plots. There's actually more than 5 box plots. There's how many box plots do we have here?
6,
35
8.
box plots.
Oh, 8.
Does that
Oh.
mean people are shallow, Yesenia? Yes, it does. if yes, that's 100% what it is. That's exactly right. Okay, no question about it. Okay, so there's 35 box plots in this table. One page, 35 box plots. That's a significant amount of information. Okay. So in general, were people who were rated higher on these categories more desirable as a date than those who rated lower? Yes, whether it's attractiveness, fun, even intelligence to some extent, ambition, sincerity, as a general rule, the higher you rate, the more desirable you are. Okay. Is there a category that contains an exception to your answer in part A? Is there a category where something just is not what you expect?
Well, intelligence, right? Because it's kind of like a bell shape where it goes up and it reaches a peak and then comes right back down.
That's right. And I know people who specifically will not date someone smarter than they are because they want to be the smart one in the relationship. Okay, I know people like that. Okay.
Ooh.
Well, I'm not saying it's anyone. I'm not gonna. It's just you don't know who I know. Oh, it's John. Oh, John. Sure, that's the one. Yeah. Okay.
Yeah,
anyways.
John.
All right. Anyways,
John is so the type.
you want? Yeah. I'll give you his number.
No, like he's the type to do that.
To not date someone smarter because you want to be the smartest one.
Yeah.
Yeah, I hear that. That's why I have a hard time. I get it. All right. So, what seems to be the worst category or categories in which to have a low rating? If you have a low rating, and if there's one category that you would put a low rating in, that you do not want to be in this category with a low rating, which one would it be?
Attractiveness.
Attractiveness.
Or fun.
Well,
the
even
intelligent?
Fun.
well, even intelligence, you could be really a 5. And first of all, notice by the way something interesting. Attractiveness goes all the way down to 2, but intelligence does not. It goes to a 5. We actually don't have data for a 1, 2, 3, or 4. Right? It could very well be that for a 1, 2, 3, or 4. Hey, Liam, don't do that. Jeez. Okay. List 3 things about your data, or list 3 things that you find interesting about these data. List 3 things that you find interesting.
Three things. Well, one thing, it looks that intelligence, ambition, and sincerity are all kind of the same.
Well, the bell curve of intelligence, right? The fact that it goes up and then goes down again. That's interesting. Okay.
Could one also be what you just said, because attractiveness is the only one? Well, attractive and fun start at 2, but the other ones start at 4 and 5.
Right. Well, with that's certainly interesting that you're not given the same spread for all of them. So it's really hard to compare them across the board, right? That's certainly interesting. I mean, everyone would find different things. I mean, personally, I find even if you look at the attractiveness, notice that for number 9, that there's still an outlier down there where there's a dot on the bottom at 20%, right? Which means that even for very attractive people, there's some who would say no, thank you. Maybe they want to be the more attractive one in the relationship, right? I mean, that's obviously my problem, so,
Maybe you should talk to John about that.
I should talk to John about that. Yeah. And Lori, we'll talk to your son as well, the 6'3" giant. Okay. Anyways, so.
Hey, wait, can I ask a question?
No.
Just, okay.
What's your question?
The numbers on the bottom are like 2, 3, 4, 5, 6, 7, 8, 9. That is what? Because now I'm losing my place as far as like.
So basically, let's say 1,000 people looked at someone, and they rated it. Or let me rephrase this. Everyone goes on dates, right? There's thousands of people who are going on dates, and we collect all this data that says that a number of people rated this person, let's say, as an 8 attractiveness, right?
So every 2 people rated fun at 0. Am I reading that right?
No, what it means
No.
is the following. If there was a person whose median rating on fun was a 2, so if there was a person where the median rating for that person was a 2, the data shows that nobody wanted to go out with them. Not a single person, 0%.
Oh, and then the median rating was a 3.
If the median rating was a 3,
2%.
then we see we have a range of people up to 38, 35, whatever that is.
So it was those other ones turned this way now. The flat box or whatever.
So the bottom
Box
number,
plot.
the bottom number is the median rating that was given to that person.
Yeah.
Okay. Then the question is who wants to go out with them? Okay. So you have I guess, how do I say this? Let me try to find the words. Hold on.
Must be the worst. It might come when. Did you already answer this question? What seems to be the worst category or categories in which to have a low rating?
That's
that
intelligence, right? So,
And because the numbers don't go very high, or the median, that's okay. You can move on. I'm gonna have to go back.
I'm trying to talk myself into understanding this as well. Because hold on, that's why I'm going back up to it. So,
I can go back and listen to the video.
rightmost box in the set of box plots on attractiveness represents all of the people who got a median rating of 9. So this is not just one person. This is a bunch of people. Okay, there we go. So the 9 rating here is a collection of people, right? It's not one person who got a 9. Hundreds of people could have gotten a 9, right?
Right.
There's a lot of people in here. And for each one of those people, for each one of them, a certain percent would want to go out with that person. Okay, so for example, for one of the people, it might be 80% wanted to go out with them. And for one of the people, maybe it was 65% that wanted to go out with them. And for one of those people, only 20% wanted to go out with him or her.
That lone dot right there. Yeah.
That lone dot. And you know what it could be? You know, listen, attractiveness is one thing, but the guy could be so arrogant, or girl, you know, you never know, but we'll assume it's a guy, could be so arrogant and so
stinks.
Yeah, it's just, people just will say, you know what, this guy is just, there's something off about him. Right? So you're going to have outliers. You're going to have people who buck the trend a little bit. Okay? That's always going to be the case. But the point here is, the overall point here is that you can do a lot of information with box plots. Okay? And also notice, by the way, above, the box plots were all sideways and these are all vertical. And no one said, hey, what happened there, right? You can do a vertical box plot, a horizontal box plot. It makes no difference. You still have minimum, Q1, Q2, Q3, and the maximum.
And it's just basically, instead of having these super huge graphs or whatever, it's information that's put into a smaller thing.
Yes.
That shows ranges.
Any visual display of data is designed to encapsulate information in a succinct way. Yeah, I'm fine. I've had some pain the last few days, but I'm okay. Thank you. So, are there any questions on what we went over today?
A lot.
A lot. Well, that's why we go over it, right? And hopefully the videos.
Hopefully some will stick.
No, it's not Advil. It's something more serious, I think. But what I'm going to do, by the way, is as follows. Does anyone still look at the old videos? Let's say the first 10 lectures.
Yeah,
You do, okay, because I was thinking perhaps the reason why the upload speed is so slow is because of how many lectures are already there. I was thinking of getting rid of them, but if you're still looking at them,
Did you ask
Okay.
IT?
say again, what?
Did you ask IT if that's the case?
This is not a school computer. This is my own computer.
No, but like if it's on Canvas, that's an IT
That's
thing.
true.
It's probably
That's
not your
true.
computer.
That's true. That's a good point. I'll email them. That's a good point.
or
For
set
class
up,
time?
And I'm
you
gonna
could
stop
set up a
recording now.
separate classroom or something.